All right, students, we are now in section 6.1. We're taking what you learned last year and going further with it. So, let's first start with what you're going to learn. You're going to learn zero and negative exponents, using the properties of exponents, and using them in real-life problems. This video is broken up into two parts. This is part one. So, this you learned last year, but we're going to review it because we're going to do harder problems this year. So, zero exponents. For any non-zero number a to the 0th power is 1. But the power, 0 to the 0 power, is undefined. Make note of that. So, for example, if you had 4 to the power of 0, your answer would be 1. A to the power of 0 is 1, where a cannot equal 0. And negative exponents. Ooh, we have more here. Negative exponents. For any integer n and any non-zero number a to the negative n power is the reciprocal of a to the n. So for example, 4 to the negative 2. That's like saying 4 to the negative 2 over 1. You're going to move it to the bottom. And when you move it to the bottom, it becomes positive. So you're going to get 1 over 4 squared. Now 1 divided by 4 squared is going to give you 1/16. So if I had this, a to the negative n, that would become 1 over a to the n power. So example 1. Let's use 0 and negative exponents and evaluate each expression. So we're going to write some examples down. Let's start with A. 6.7 to the power of 0. Since 6.7 is to the power of 0, we're just going to write 1. B. 5a to the power of 0. And then we're going to write down C. 5a to the power of 0. These are completely different answers. So this is where you have to realize that parentheses make the whole world of difference here. In the first one, 5a to the power of 0, this really means 5 times a to the power of 0. Well, a to the power of 0 is 1, and 5 times 1 is 5. So in this case, you're only taking the a to the power of 0, not the 5. Now in C, we're taking the 5 and the a both to the power of 0. So this one's just going to give us 1. All right, let's go to D. Negative 2 to the 4th power. Negative 2 to the 4th power. Okay, so let me explain this to you. Negative 2 to the negative 4th power. You cannot have negative powers in a simplified expression, ever. Now, the negative out front here, the negative 2, that is just a normal negative 2. So that is not an exponent. You cannot have this negative 4 to be as a power. So what we're going to do is take the reciprocal. We flip the entire thing, and the power becomes positive. So this becomes 1 over negative 2 to the 4th power. Now you must leave your negative 2 in parentheses. Now, if you simplify that, that becomes 1 divided by, well, what's 2 to the 4th power, or negative 2 to the 4th power? Well, negative, hopefully you know this, a negative to an even power is always positive, and 2 times 2 times 2 times 2 gives us 16. So we would get 1/16 as your answer. Now I'm going to do another problem, and this may make a little more sense. C to the negative 3, D, all over b to the negative 2. Now in this problem, we have negative exponents, which we cannot have. Basically, you take the reciprocal, which means it reverses. So the c to the negative 3 is going to move to the bottom. The b to the negative 2 will go on top. And when you do that, they become positive. So this would become b squared d over c to the third. Now, why did the d stay on top? Because it already has a positive exponent, so we don't need to move it. So I've already kind of led into our example 2. We're simplifying expressions. So let's simplify this expression. 4x to the 0 power divided by y to the negative 3. So the first off, the 4 does not change. So the 4 stays on top. X to the 0 power becomes 1. So that's 4 times 1, which we don't need. And then the y to the negative 3 goes on top. And when it moves, it becomes a positive power. So that becomes 4y to the third. There's nothing left on bottom, so that's just 1. And so your answer is 4y to the third. Now if I gave you another example, let's do negative 3 x to the negative 2 power. Now in this problem, what are you taking to the negative 2 power? It's only the x. So this is the only thing that moves, and it goes to the bottom. So x to the negative 2 would go to the bottom and become x squared. That's it. That's your answer. Now h, example h, negative 3x to the negative 2. Everything is being taken to the negative 2 power. So that would become 1 over negative 3x squared. Now, that's not simplified, but you're going to find out in a little bit what happens when you do simplify that. All right, so let's do some examples. Now, all of these, you're more than welcome to skip over this part, but pause the video and try them yourself. So number 1, negative 9 to the 0 power gives me 1. Number 2, 3 to the negative 3 power, that gives me 1 over 3 to the third power, which gives me 1/27. In number 3, ooh, this is a good one. Number 3, you are only taking the 5 to the 0 power. So you're actually going to get negative 1 on top. And then on bottom, you get 2 to the negative 2. But then that has to go to the top because it has a negative exponent. So this would become negative 1 times 2 squared, which would end up giving us negative 4. That's confusing for students. Do another example of that. I'm just going to do quickly 2 more examples. If I have negative 7 to the 0 power, that just gives me 1. If I have negative 7 not in parentheses to the 0 power, you are only taking the 7 to the power of 0, because really this is just negative 1 times 7 to the 0 power. So this right here becomes 1. The negative comes down. So if you need to look at number 3 again, please ask in class or please ask me to do another example. I'll be more than welcome to do that for you. Number 4, 3 to the negative 2 power, x to the negative 5th, all over y to the 0. Well, y to the 0 becomes 1. These two both have to go to the bottom. That means on top, I have a 1 left. There's nothing there. So on the bottom, that gives me 3 to the 2nd power, because it's just a positive exponent, x to the 5th, and if I simplified that, that would become 1 divided by 9x to the 5th power. All right, our next core concept is using the properties of exponents. So we have 3 of them. The product of powers property, that says we're going to multiply powers together. So to multiply powers with the same base, you add their exponents. So here we go. To multiply powers with the same base, add the exponents. So if I had 4 to the 6th power times 4 to the 3rd power, you get 4 to the 9th power. All you do is add the exponents together. In the algebra form, a to the m times a to the n, you add together m plus n, and you get a to the m plus n. A is the real number, m and n are integers. Now, quotient of powers property. Now we're going to divide. It's just the opposite. When you multiply, you add the powers. So when you divide, you subtract the exponents. So when you multiply with the same base, you add the exponents. When you divide, you subtract. So 4 to the 6th power divided by 4 to the 3rd, we just subtract the exponents, and we get 4 to the 3rd power. So that would look like this. A to the m divided by a to the n would give us a to the m minus n. Now, a cannot be 0. And power of a power. This says that to find the power of a power, you multiply the exponents. So this is when you have one base with a power to a power. So you would take 6 times 3, that would give us 18. Now why does that work? Because if I took 4 to the 6th power times itself 3 times, because that's what this says, 4 to the 6th to the 3rd, look what I have. I have the same base. What do you do with the powers when you have the same base? You add them. So that would give you 4 to the 18th, which is the rule up here that we've already used. So we can always now use it as a shortcut rather than actually showing those steps. So as algebra, a to the m to the n would give us a to the mn. So example 3, using the properties of exponents. So let's do example A. 3 squared times 3 to the 6th. Since we have the same base, we add the exponents. That's the product of powers property. So that gives me 3 to the 8th power. Now, we'd actually not write that as our answer, so I'm going to erase that. We'd go one step further and actually figure out what that is. 3 to the 8th power gives us 6,561. B. Negative 4 squared divided by negative 4 to the 7th. So negative 4 squared divided by negative 4 to the 7th, that gives me, same base, so that gives me, where are there more negative 4s? There's more on the bottom. So I'm going to show you a shortcut here, but let's first do this like we've done before. So we subtract the powers, 2 minus 7. That gives me negative 4 to the negative 5th power. Well, we can't have a negative power. So then that becomes 1 over negative 4 to the 5th power. And negative 4 to the 5th power will give us a fraction of negative 1 over 1,024. Now some of you may say, well, why did the negative go on top? Because whenever you read a fraction, the negative always goes on top. So negative to an odd power is negative, and 4 to the 5th power is 1,024. Now there's a shortcut here. I could have looked at both of these and I could have asked you this. Where are there more negative 4s? On the bottom. How many more negative 4s are on the bottom and the top? We have 2 on top and 7 on bottom. So how many more do we have on bottom? We have 5. So you could have skipped that step here. And you have 5 more on the bottom. So wherever there are more is where you're going to have negative 4 to whatever power that is. C, z to the 4th to the negative 3. I have one base and a power to a power, so that becomes z to the negative 12th, which we cannot have. We have to take the reciprocal of z to the 12th, so I get 1 divided by z to the 12th as my final answer. If you'd like to pause the video and try these yourself, you may. Number 5, 10 to the 4th times 10 to the negative 6. I add the exponents, same base. That gives me 10 to the negative 2nd, which is not simplified. That becomes 1 over 10 squared, which gives me 1/100th. Number 6, x to the 9th times x to the negative 9. I add the powers, I get x to the 0. Anything to the power of 0 is 1. Number 7, I have negative 5 to the 8th power divided by negative 5 to the 4th power. This gets a little weird. This is not negative 5 to the 8th. It's just 5 to the 8th. So this is really, it looks like this. Negative 1 times 5 to the 8th over negative 1 times 5 to the 4th. Well, negative 1 divided by negative 1, that just gives me 1. And then where are there more 5s? There are more 5s on top. There are 4 more 5s on top, so we just subtract them, 8 minus 4. And 5 to the 4th gives me 625. Number 8, I subtract them. Where are there more y's? Where are there more y's? There's more y's on bottom. How many more y's? Just 1, so I get 1 over y. Here, power to a power, I multiply. That gives me 6 to the positive 2 power, which gives me 36. And lastly, I multiply 5 times 12, and 12 times 5 gives me 60, so my answer would be w to the 60th power.